Types of organic reactions and their mechanism. Okay, that is the topic for today, because basic preliminary things, effects, etc. I have already discussed. So now I am going to start the different type of organic reactions and their mechanisms. These are the types of reactions: substitution, elimination, condensation, addition, rearrangement and isomerization. These are the types of reactions.
So condensation.
Condensation means one molecule will enter, another molecule or species will go out. Okay, that is substitution. Acha. Now condensation is two different molecules just getting added up, followed by release of a small molecule. Okay, I will clarify. Addition, two molecules getting added up. Substitution, one molecule is entering, another molecule going out. And condensation is two molecules are getting joined together, and followed by release of a small molecule, like water molecule going out or alcohol molecule going out. This type of reaction is called condensation. Then elimination. What is elimination? Elimination is release of a molecule, not getting added up, but directly getting released. That is elimination. Then rearrangement. The molecular structure is getting reoriented itself. The structure is getting changed internally. That is rearrangement. Okay. Then isomerization. Why one isomer is getting converted to another isomer. That is called isomerization. What is the difference between rearrangement and isomerization? Isomerization means one isomer to another isomer, and rearrangement means the structure gets changed and it is not becoming the same molecule anymore. It is a different type of molecule, like branching of a straight chain hydrocarbon. Originally it is straight chain hydrocarbon, like N-hexane. It is becoming isohexane. N-pentane becoming neopentane. These type of things are called rearrangement reaction.
Addition and substitution reactions. In this module, you will learn about the addition and substitution reactions of carbon compounds. Shown here are the molecules of two carbon compounds, methane and ethene. As you already know, methane is the simplest saturated carbon compound, whereas ethene is the simplest unsaturated carbon compound having carbon-carbon double bond.
Hey, stop talking!
What happens
Stop talking immediately!
compounds are made
Continuously gossiping.
with the same reactant, chlorine, under suitable conditions. Let's first check out the reaction of ethene with
Now, addition reaction that happens mostly for alkenes like ethene. Okay, so where ethene, propene, butene, butadiene. So this type of compounds you expect addition reaction, and it is called electrophilic addition. Additions can be again two types, electrophilic and nucleophilic. So whenever there is a double bonded carbon compound, carbon-carbon double bond. Hey, why not listening? Why not listening? You know everything? Do you know everything? Don't know? Then just listen. Don't talk. So ethylene, propene, butene, butadiene, these type of compounds, there is symmetric electron density. Symmetric electron density. What is the meaning? It is non-polar compound. Okay, the electron distribution is totally distributed equally in all directions. That is called spreaded equally, both sides. Carbon-carbon double bond. The electron is distributed equally in the whole region of the molecule. That is called symmetric distribution. That means non-polar. Simply we call it non-polar. So in case of such non-polar molecule, electrophilic addition takes place. First of all, some electrophile will enter, followed by some nucleophile. Addition means there will be addition of one electrophilic part, another nucleophilic part. Both will be added up. But question is which one is getting added first? In case of electrophilic addition, electrophile is getting added first, followed by nucleophile. And in case of nucleophilic addition, first the nucleophile getting added up, and then the electrophile. Now, if it is evenly distributed electron density, then nucleophile cannot penetrate because of inter-electron repulsion factor. That's why electrophile will enter, not the nucleophile. But if the molecule has got uneven electron density, uneven means polarity there. If there is a polarity, in that case you will find the nucleophile is getting added first, followed by the electrophile. That is the basic difference. So nucleophilic addition means first addition of electrophile. Electrophilic addition is first addition of electrophile and then nucleophile. And nucleophilic addition means first nucleophile, then electrophile. Both must be added up, but which one is first and which one is later, that depends. Now you have a double bond, propene, add HBr. HBr will be ionized in aqueous medium, producing H plus plus Br minus. First of all, H plus getting added, electrophile, then Br minus is getting added. And by this mechanism, what you are getting is CH3, CHBr, CH3. That product you are getting. CH3, CHBr, CH3. That product you are getting. But if you have some polar molecule like RCHO, that means C delta plus and O delta minus. In this type of molecule, the electrophile cannot approach first. Okay? Because there is delta plus delta minus character, uneven electron. So in this case, nucleophile can easily enter. Where? To the carbon. So nucleophile will attack at the carbon, followed by the electrophilic addition. So that is called like cyanohydrine formation. First Cn minus getting added and then H plus. Okay. So that way the reaction will proceed, and that is called nucleophilic addition. Okay. Let's go ahead. Some things you can find it here also.
The presence of the double bond makes ethene quite reactive. When we add chlorine to ethene in the presence of ferric chloride, the double bond of ethene breaks partially. The two carbon atoms in turn combine with one chlorine atom each, thereby completing their valency. The compound so formed is 1,2-dichloroethane.
Now, if you consider this reaction, how the reaction will occur? It can be if you add this FeCl3. So you cannot use aqueous solution, because in this case this FeCl3 itself will be hydrolyzed in aqueous solution. Hydrolyzed, it will produce FeOH3, and hydrolysis means some salt plus water giving you the precipitate, some sort of precipitate, some sort of reaction like that. If you take some FeSO4, adding to water, you are getting FeOH2 plus H2SO4. So that is the back reaction. Acid plus base, you are getting salt plus water. Salt plus water, you are getting acid plus base. That is called hydrolysis. That is the back reaction. And that happens. There is a proof. What is the proof? You take a pinch of some salt, acidic salt or basic salt, and put into water. It is hydrolyzed, producing some acidity or basicity. It is no more neutral. If you take NaCl and put into water, the water will be neutral. It will not be changed. The pH will not be changed. It will be neutral. But if you take FeSO4 and put into water, you get some acidity. Why? Because FeOH2 plus H2SO4 will be formed, and H2SO4 will make the whole thing acidic, because FeOH2 that is getting precipitated partly getting precipitated. And if not, then also it is not a very strong base. And comparatively H2SO4 is a strong acid. That's why overall the solution will become acidic. Okay, copper sulfate put into water, it will become acidic because of sulfuric acid. So you may think that salt plus water, acid plus base, how it is possible? It is a back reaction. Always forward and backward reaction is there. So here this is the back reaction. Now why not NaCl? If you put NaCl into water, you are supposed to get NaOH plus HCl. That is happening, but you could not understand, because H plus and OH minus concentration here is the same, because both are strong. NaOH is strong, HCl is also strong. So if the NaCl gets hydrolyzed, you get NaOH plus HCl. Both are equally strong. So that's why H plus and OH minus concentration same. And you don't change any, you cannot observe any change in pH. So that's why you cannot understand actually that hydrolysis had happened, but actually happened. So back reaction is always there. So that is hydrolysis. Take salt and put into water, it is hydrolyzed, giving you some acidity or alkalinity. Sometimes, not always, because why not always? I already explained. Suppose if you put NaCl, it will not give any acidity or basicity, nothing, because both are equally strong. But it is not like that always. Sometimes the acid part is stronger, sometimes the alkali part is stronger. Accordingly, you find after hydrolysis, the mixture is either acidic or basic. So that's the thing. But what is acid salt and basic salt? Do you know? This is not same, something different. What is acidic salt? Do you know? NaHSO4. NaHSO4. It contains H plus. It is not completely neutralized by NaOH, partly neutralized. It is called acid salt. Got it? So similarly, CaCl2 is neutral, but if it is some in CO3, calcium carbonate, neutral. But what about CaHCO3 whole 2? Is not neutral.
Acidic.
Yes, so that is the thing. It can be acidic or alkaline depending on how many H plus or how many OH minus are neutralized and how many are not neutralized. If it is completely neutralized, it is called neutral salt. But if it is not completely neutralized, we can call it acid salt or basic salt. But that does not mean it will give acidity or basicity in the solution. It is not indicating that. It is indicating how many number of replaceable hydrogen present, how many number of replaceable hydroxyl present. That is called acid salt, basic salt. So basic minimum idea you should have. That's why I am just adding it here. Ajay, by the way, here in this case, what is the mechanism here? This FeCl3 has a tendency that it can accept the Cl minus from here. Why? Because it has got a vacant orbital in iron. Iron has got a vacant orbital. So it can accept vacant d orbital. Vacant d orbital present in iron. So because this is d block element and what more? It is called transition elements, and that's why it has a natural tendency to accept some electron whenever available. So it can accept Cl minus from here, producing FeCl4 minus plus Cl plus. So this instead of just like carbocation, here Cl plus chloronium ion is formed. Chloronium ion.
But sir, there is the electronegativity is same, so they form the radical.
No, not radical. Depends on what medium you are using and all. FeCl3 you are using. So FeCl3 is a Lewis acid. So it is reacting with chlorine Cl2 and producing Cl plus.
If we use sunlight,
No, depending on medium, I'm telling you. This Cl is possible. It is in sunlight medium. It is possible. In heat, if you apply heat, also it is possible. 400 degrees centigrade heat, if you apply, it happens. Even substitution also happens. That is also by radical mechanism. But always not radical. Now, which one is easier, radical or ionic? What do you think? Ionic is easier. Radical is not that easy. Ionic is easier, and radical will happen whenever there is a specific condition like heat or sunlight, diffuse sunlight. Then reaction may proceed. Okay, but that will be non-polar medium. And if polar medium, some sort of polarity present, it will follow polar mechanism. So here, FeCl3 will react to Cl2, producing FeCl4 minus plus Cl plus. So this Cl plus will attack here, producing this chlorine is getting added here. So there will be formation of a carbocation. Cl plus getting added. So it will give some carbocation. Now in the next stage, it will react with another chlorine molecule, giving you Cl plus back. Because it has to complete the reaction, or otherwise the FeCl4 minus can supply the Cl minus back. Because FeCl3 acting as a carrier over here, just like a catalyst.
Cl plus कैसे हो सकता है?
हो रहा है, होता है. There is a lot of evidence and proof. होता है. So here, no, that is the mechanism in the way. It is not a permanent product. Cl plus is produced, getting added up, then Cl minus is also taken up. So ultimately Cl2 is getting added. Ultimately what is getting added? That is Cl2. Both the carbon 1 Cl getting added. Okay, so dichloro compound is formed. So first Cl plus, then Cl minus. That is the mechanism. So Cl plus addition, what do you call it? Electrophilic addition. Because first Cl plus is getting added, followed by Cl minus. Okay, that's why. How do you know that? Otherwise, circumstantial evidence. This molecule is a non-polar molecule. Cl minus obviously cannot attach. So ultimately you are getting the product, Cl are getting added. So how do you suggest? What do you suggest then? How chlorine is getting approached? How chlorine is approaching? How chlorine is approaching? How chlorine is approaching? It has to be Cl plus, otherwise it is not possible to approach because Cl minus cannot attack here. And radical, we are not giving some radical initiator here. So radical mechanism is not possible until unless we are giving some initiator. Radical, if you want to add radical mechanism if you want to suggest, then you have to give some initiator that initiates the radical. Radical cannot produce by itself. Either you are giving some sunlight, diffuse sunlight, high temperature, otherwise not possible. But here it is so simple. You are just add this and this, it is getting added up. No drastic condition. So without the drastic condition, chlorine atom not possible. So how the mechanism can proceed? This is the suggestion. You can, if you give some better logic, you can, it is acceptable.
Why the Cl plus added up first?
Because Cl minus will be repelled back. Cl minus is minus, and
Because
this
of the double bond?
the bulk one means high electron density. So there Cl minus cannot approach. So Cl plus must be approaching. So that is the logical explanation actually. So Cl plus is added, then followed by Cl minus. Okay, let's go ahead. Next point.
And it is a saturated compound. Let's now check out the reaction of the compound methane with chlorine. When methane is made to react with chlorine,
See, here radical mechanism. Because diffuse sunlight required. If you compare the two, you will understand. Here sunlight is required, without sunlight this reaction is not occurring. That means this sunlight is breaking the chlorine molecule into chlorine atom. And it is occurring in the gaseous state, not in the aqueous solution. That is the basic difference. There you need some solvent, here you don't need any solvent. So here chlorine atom, rather solvent if there, it will not follow radical mechanism. And it may happen, but in that case non-polar solvent you will have to apply. Sometimes non-polar solvent or in the gaseous state, the reaction will proceed. So here Cl will produce Cl dot plus methane CH4 giving you CH3 dot plus HCl. By mistake some are making CH3Cl plus H dot, that is not possible because H dot has got no stability. So this CH4 plus Cl dot will give you HCl plus CH3 dot because CH3 dot has got certain stability, it's an intermediate. It is called free radical. CH3 dot is called free radical, methyl free radical. It has got existence. Methyl free radical, propyl free radical, ethyl free radical. Actually they are forming. One example, in the this type of gasoline when you are using into vehicle, they are producing lot of radicals. And that radical is giving knocking sound. Okay, so there is a problem in the petrol engine called knocking. Knocking, do you know? Knocking means some sort of peculiar noise or sound coming from the engine, and that is because the premature combustion taking place. Premature combustion. Okay, it occurs in 4 steps. First the fuel should enter in the engine, then after that compression takes place, followed by spark plug ignition, and then finally exhaust stroke. So these 4 strokes are there. But sometimes what happens, because of straight chain hydrocarbon, in the compression step itself, before the ignition, the combustion starts itself, by itself, because it is highly active, too much of reactivity. The radicals are generated which are highly reactive, and that's why the automatic trigger reaction takes place. That you cannot control. It is going beyond, out of control. And that is giving, it is called premature combustion, called knocking. And because of knocking, you are getting some peculiar noise and very low efficiency of the engine. Mileage, low mileage. Very simply, low mileage. Okay, that can be prevented by converting straight chain hydrocarbon into branch chain hydrocarbon. That is the importance of rearrangement. In the list there was a term, rearrangement reaction. So this is the importance of the rearrangement reaction. If you convert the straight chain hydrocarbon into branch chain, this problem can be from the beginning curtailed off. We can minimize that problem. That is called knocking problem. So what is the benefit? Minimization of this knocking. And knocking gives low efficiency. Low efficiency means poor mileage. Poor mileage means more of our money will be spent. Okay? So we can save the money by doing this process. What process? Rearrangement reaction. Straight chain hydrocarbon converted to branch chain, and branch chain is hydrocarbon is not doing that knocking. That knocking is not happening for branch chain. It is happening for straight chain. That is the importance. It is called reformation of petrol. This particular term, it is called reformation of petrol. What do we do it? We do that straight chain to branch chain hydrocarbon conversion. That interconversion we are doing with some catalyst. Okay. So here what I was telling, that chlorine will produce atom, that is initiation. I told now, without initiator, reaction cannot proceed in case of radical. So this is what is the initiator here? The sunlight. So with that initiator, the initiation reaction starts. We are getting chlorine atom. Atomized chlorine reacts with methane, producing HCl plus CH3 dot, which is methyl radical. Those methyl radicals are highly active, super active. So it can break another molecule of chlorine, producing CH3Cl and Cl dot back. And that Cl dot is acting as this atom, Cl dot is acting as a catalyst, because once you are using it and then you are getting it back. So acting as just like a catalyst, not catalyst actually. So it is go on reacting like that. It is called propagation. One chlorine atom knocking methyl, producing methane and chlorine, producing methyl chloride plus HCl plus methyl radical. HCl plus methyl radical. That methyl radical, as it is super active, it is reacting with another chlorine molecule, producing CH3Cl plus Cl dot. So you are getting the Cl dot back. That Cl dot is again knocking another molecule of methane, producing methyl chloride and another Cl dot. So that way Cl dot is continuously producing. That is called propagation. And no further initiation is required. Initiation, that is the starting point, that is the doing the reaction, triggering the reaction. Once the reaction is started, don't need further provocation. It does not need any further provocation. Reaction will automatically proceed. That is called propagation. And at the end what will happen? Cl dot plus CH3 dot CH3Cl. Cl dot plus Cl dot Cl2. CH3 dot plus CH3 dot C2H6. Coupling, doubling. That is taking place. That is called termination. And when it will occur, either chlorine is consumed totally or methane is consumed completely. Then only termination will take place. First initiation, then propagation, followed by termination. 3 steps. This is called radical mechanism. Applicable in all type of radical mechanism. Anti-Markovnikov addition, radical mechanism. There also the same way reaction proceeds. Any type of polymerization reaction, you have heard polymer, monomer to polymer. So monomers are getting added up by radical mechanism. Like polythene, it is by radical mechanism, ethylenes are getting added up, producing a polymeric chain, that is called polythene. Now how many number of such small molecule getting added up? That is called degree of polymerization. The chain length, how many number of monomer unit getting added? That is called degree of polymerization. If it is very long, very high, then it is called high density polyethylene. If it is smaller chain, we call it low density polyethylene. Got it? LDP, HDP. LDP means low density polyethylene when chain length is short, and if the chain length is high, then it is called HDP, high density polyethylene. And if the chain length is very high, then it is called ultra high density polyethylene. So different grade of polymer we are getting. Accordingly, we are using in different purpose. Sometimes polyethylene is good enough, sometimes HDP, LDP or UDP, depending on the purpose. What you want to do accordingly. You have a big container, very tough material required, Syntex tank, that type of huge material, so big barrel. Then you are using ultra high density polyethylene because it will last much longer. Okay, but mug, jug, bucket, small things, articles, household things, there we are using low density polyethylene because cheaper. Ultra high density will be very costly.
So lasting is depend on the degree of the
Quality, yes.
In the presence of sunlight, one of its hydrogen atoms gets replaced by a chlorine atom. The product so formed is chloromethane. If the reaction is carried out with excess of chlorine and continuous exposure to sunlight, the chlorine atoms replace all the hydrogen atoms of methane one by one, giving rise to the products dichloromethane, chloroform, and carbon tetrachloride. So you have seen how differently chlorine reacts with two carbon compounds, ethene and methane. In case of ethene, the chlorine atoms add to the carbon atoms after partial breaking of the double bond. Since this reaction involves the addition of new atoms, it is known as the addition reaction. Ethene is not the only unsaturated compound that undergoes the addition reaction, but other unsaturated compounds also undergo the addition reaction under suitable conditions. These addition reactions of carbon compounds take place in the presence of some other compounds like ferric chloride, as in case of addition reaction of ethene and chlorine. Compounds like ferric chloride do not undergo any permanent change in them, but increase the rate of reaction. Such compounds are known as the catalyst. Some addition reactions of carbon compounds have industrial significance also. One such addition reaction is hydrogenation of the vegetable oils. Vegetable oils are long-chain unsaturated compounds. They undergo the addition reaction with hydrogen in the presence of nickel or palladium to form the vegetable ghee that are saturated compounds. Let us now get back to the reaction of methane with chlorine. Yeah? Chlorine atoms replace or substitute the hydrogen atoms of methane. Since the reaction involves the substitution of hydrogen atoms with other atoms, it is known as the substitution reaction. Methane is not the only saturated compound that undergoes the substitution reaction. Many other saturated carbon compounds undergo the substitution reaction under suitable conditions. Since saturated carbon compounds are fairly unreactive, therefore, their substitution reactions take place in the presence of sunlight. Let's recap. The reactions that involve the addition of new atoms to unsaturated carbon compounds are called the addition reactions. Hydrogenation of a vegetable oil to form vegetable ghee is an example of addition reactions. Addition reactions of carbon compounds take place in the presence of catalysts. A substance that does not itself undergo any permanent change during the reaction but increases the rate of the reaction is known as a catalyst. The reactions that involve the substitution of hydrogen atoms of saturated carbon compounds with other atoms or groups of atoms are known as substitution reactions. Substitution reactions of many saturated carbon compounds take place in the presence of sunlight.
Alright, so understood what is addition and substitution. Addition means just getting added up by some means, maybe sunlight, maybe FeCl3, some sort of catalyst or without catalyst, maybe catalyst or maybe without catalyst. Like bromine, if you just add bromine water and take bromine water and pass ethylene gas through that, bubbling through that. So there also you will find the bromine water gets decolorized. What is the color of bromine water? What is the color of bromine? Red color. Red color. Red means not blood red. Reddish brown type of color. Yes. So there if you continuously pass some ethylene or propene type of double bonded compound called olefins in general, if you pass through that, it will absorb this bromine and doing the reaction. It is the addition reaction. And that's why you will find it is the bromine water becoming colorless. So that means in this case you are not adding any catalyst, nothing, but automatically getting added. How possible? Br plus and Br minus is taking place without any FeCl3. In this case I told FeCl3, na? Without any FeCl3 also this reaction happens. You take bromine water, pass any type of ethylene or propene, this type of gas, that olefin gas, pass through, automatically you see the solution will become decolorized. That means reaction is happening. And what is getting affected? The double bond. The double bond is broken and their bromine is getting added up. So that is called addition reaction. That is the proof of your unsaturation. Proof of unsaturation. That is the test, specific test for unsaturation. If you want to know some unknown compound given to you, okay, some unknown compound, entirely unknown. So whether there is unsaturation or not, if you want to simply test it, take some bromine water or potassium permanganate solution and bubble the gas through that. gaseous compound it should be, then you will find bromine water or KMnO4 solution becoming decolorized. That means some reaction taking place. That is the proof of unsaturation. So unsaturation is there or not, you can test easily like that way. Okay. Now coming to next type, nucleophilic substitution. Here OH minus is some nucleophile. It is replacing X minus, taking its place, giving you alcohol. So alkyl halide converted to alcohol by treatment of hydroxide. This is called nucleophilic substitution because one nucleophile entered, another nucleophile gone out. Which one is entering here is called entering group, and the one that is going out is called leaving group. Both are nucleophile, must be, and that is called nucleophilic substitution. One nucleophile enters and another nucleophile goes out. That substitution taking place, it is called nucleophilic substitution. Now RO minus, give ROR, ether. CN minus getting added up, replacing, one replacing another. So these are all very common reactions. Lot of example. Now types of substitution reaction: nucleophilic, electrophilic, and radical. Radical substitution already you have seen right now. That was radical substitution. So Cl getting added up in both the double bonds, is double bond is broken and chlorine is getting added. Double bond is broken, bromine is getting added. KMnO4 doing the hydration reaction. So these are all addition reaction, but these are radical reaction. Bromine addition, chlorine addition, these are radical reactions. Okay, sometimes radical, sometimes depending on whether you are using some sunlight or catalyst like that. Okay, so radical reaction, chlorine getting added up. Very simple. You take a double bonded compound and give chlorine and raise the temperature to certain degree. Double bond will be broken and chlorine or bromine will be added up there. That is by radical mechanism. In that case, you are not having any solvent, gaseous state. So how the reaction is taking place then? Radical mechanism. In that case, radical mechanism. Because at a high temperature, chlorine is broken into chlorine atom. Atomized chlorine takes place doing the reaction. And chlorine, when it is atomic state, it can jump into any double bond, whether it is a polar or non-polar doesn't matter much, because high temperature reaction or photochemical reaction, the chlorine or such atom is so energized that they don't need any type of solvent also, neither they need any catalyst, where they are super energetic. They are super energetic. Easily it can penetrate into any double bond anywhere. Okay.
By the substitution reaction, the molecule get more stability?
Not always, not necessarily. Okay, that confusion I think is still there. Earlier I told also. Not always. This is one situation, and this is another situation. We have reactant, product, reactant, and product. In this case, this is energetically lower. This product energy is lower, that means more stable. But here it is less stable. Delta H is positive, and here delta H is negative. Right? Okay? So according to this, the reaction can occur by this pathway and this pathway also. Both are possible. So in the upper one, the reaction can happen without getting more stability. Rather, it is becoming less stable. But still it is happening. Because molecules are not so calm and quiet. They are always moving at random, very fast movement. They are energetic. So they are always doing something, not sitting idle. Okay? So molecules are knocking each other, doing another reactant whenever coming is just colliding with that. So they are crossing the barrier. Some barrier they are crossed. If the barrier is crossed, it will have to go at a lower energy level. Compared to earlier, it can be higher energy level or lower energy level. But once the barrier is crossed, it is difficult to go back. Now that way, reaction can occur, sometimes energetically favored, sometimes not favored. But both reactions can occur. Possible. Because of the barrier. It is not always thermodynamically feasibility will take the place. Sometimes kinetic feasibility is also there. One is called thermodynamically controlled product, another is called kinetically controlled product. Suppose the barrier is smaller, barrier is less, so easily it can pass through. That's why molecules are passing through. And once it is crossing, not coming back so easily, because again you have to cross the barrier to come back. So that's why it is becoming static there. It may happen. All sorts of possibility, what I mean. Okay, more stable product can be formed, less stable product can be formed. Now, if you give sufficient time and energy, if it reaches the equilibrium, then always it will, according to thermodynamics, it will go for the most stable product. But sufficient time and energy may not be always available. Okay. So, substitution reaction 3 times, radical substitution, Cl2 getting added up, both the carbon, that is radical. Electrophilic substitution, one electrophile enters, another electrophile goes out. Example, NO2 plus entering into benzene ring, giving nitrobenzene, and H plus is released. Nitration of benzene. That is electrophilic substitution. Nucleophilic substitution, OH minus entering, replacing Cl minus. So Cl minus goes out and OH minus is entering. So you are getting alcohol from alkyl halide. That is nucleophilic substitution. This nucleophilic substitution can happen in two different ways by different mechanisms. These are all mechanisms. Up to this is types. Now coming to mechanism. It is happening, but how it is happening? Now point is, how it is happening? It can happen by so many ways. SN1 mechanism. This SN1 reaction is following SN1 mechanism path. Now SN1 mechanism means here carbocation is generated. Okay? And the reaction is occurring in 2 steps. First of all, you take an example, tertiary butyl chloride. Chlorine goes out. What you get? CH3 whole thrice C plus. It is called tertiary butyl carbocation. Now this carbocation is quite stable because of plus I effect of 3 methyl groups attached to that carbon which is bearing positive charge. The carbon bearing positive charge attached to 3 different other methyl groups, and these methyl groups are supplying some amount of electron towards this carbocation, and that's why it is getting stabilized. So this is called, I think you better write down. Write down, it will be, you will get better idea. CH3 whole thrice C plus. No, first you take CH3 C whole thrice CCl. CH3 whole thrice CCl. So got the conclusion? It is not necessary the product will be always more stable than the reactant. Not necessary. It may happen. That is supposed to be, but not always true. Sometimes you get the product which is less stable than the reactant. Okay. But why it is happening then? Cross the barrier, could not come back. एक बार चला गया तो वापस नहीं आ पाया. So CH3 whole thrice CCl is the compound. It is called tertiary butyl chloride. Now chlorine goes going out. Why going out? Because you are using aqueous medium. Aqueous medium. In aqueous medium, carbocation has got stability, and because of that stability, it is happening. As it is stable, it is produced. So you are getting tertiary butyl chloride. Now this tertiary butyl chloride is getting that chlorine is going out, producing tertiary butyl carbocation or carbonium ion. And it is sp2 hybridized. Originally, the tertiary butyl chloride was sp3 hybridized. Bond angle was 109 degree 28 minutes. But after the chlorine removed, you are getting tertiary butyl carbocation, which is having sp2 hybridization, and bond angle is 120 degree. And originally the molecule is quite bulky, so that bulkiness is gone now because it has become comparatively spacious. Bond angle is increasing, na? That's why. So in between the bond angle is 120, and molecule, and this phenomena is called release of steric crowding. Release of steric crowding. Originally it was crowded, now it is not crowded. It is called release of steric crowding because sp3 to sp2, and that's why this is one factor. Release of steric crowding is always desirable for the molecule. Number 2, once the carbocation is formed, water molecule is surrounding it to give you stability, and that is called solvent stabilization. Another factor, because of this carbocation formation, plus I effect of the 3 methyl groups is also acting here. That is giving inductive effect, what I mean. Okay, plus I effect from 3 methyl groups. Plus I, let's write down below this. So what are the stabilizing factors? Number one is plus I of 3 methyl groups. That is number one. Number two factor, release of steric crowding also is there. Okay, but inductive effect is the more prominent. Then you are having solvent stabilization. Solvent stabilization. Then number three factor, release of steric crowding, you can say. So these are the factors giving the stable carbocation. Now if the reaction happens this way, first of all the formation of the carbocation and then OH minus is entering. First Cl goes out, Cl minus goes out, and then after that OH minus is coming in. So that way if the reaction happens, how many steps we get? 2 steps. First step is the formation of the carbocation itself, and second step is addition of that entering the OH minus is entering. Okay, so there is these 2 steps. So out of these 2 steps, which one is difficult, we think? Which one is difficult out of these 2 steps?
So
First step is difficult, second step is easier. First step is endothermic, second step is exothermic. Okay, so that's why first step is difficult. That is called rate determining step, RDS. So how many number of species involved in that? Only the alkyl halide, no other species involved. So that's why it is called SN1, because it is unimolecular. There is no other molecule involved in this formation of the carbocation. That's why it is called SN1, substitution nucleophilic unimolecular. So with the example I clarified this. Then second,
third one?
no, come to second one first.
No, sir.
Third one.
Median now,
Oh.
left side.
Acha, third point, release of steric crowding.
Release of
Release of steric crowding. Originally it was bond angle becoming 120, na? Originally it was 109 degrees, now it has become 120, so release of steric crowding. I have not written here because they cannot see that. Rather you write it down. It is release of steric crowding.
solvent stabilization.
Solvent stabilization means any carbocation or any such cation surrounded by water molecules. So water molecules is a dipolar. So dipolar, the opposite pole will be attracted and it will surround it, and there is an ion dipole interaction giving the stability. That is called solvent stabilization. So only polar solvent gives this stabilizing factor. This factor is present only for polar solvents like water. Water is the most versatile solvent. So that's why you always talk about water. Other solvents, number one, you have to buy it, not free. Water is only the thing that is we are getting free. Almost free. Either free or almost free, right? But other solvents you need to buy. So why you to go to other solvent if it is not necessary? Normally we are using water most of the time in the reaction, in the laboratory. Because you don't need to buy that. Okay, very simple reason. Now SN2. SN2, what is that? This nucleophile will penetrate, another nucleophile will go out together, simultaneously. That is called SN2. And this is only one step. There will be transition state, but there will be no intermediate. No carbocation, nothing, no intermediate. There is a single step. So one nucleophile will enter and it will replace the other nucleophile, and the whole thing happen together. So as there is only one step, so that is the RDS. There is no other RDS. So that is the only RDS. So in this case, how many species involved? 2. That's why it is bimolecular. So take example, if you take methyl chloride, and from the back side OH minus attacked by OH minus, so it will become methyl alcohol plus Cl minus. That's the example for SN2 reaction. Then next coming to electrophilic aliphatic substitution. Electrophilic aliphatic substitution. One electrophile will enter and another electrophile will go out. That happens for aliphatic also. But we need some catalyst in that. Some electrophile will go and another electrophile will go out. One electrophile will enter and another electrophile will go out. That type of reaction. So an electrophilic aromatic substitution, that nitration, nitrobenzene. NO2 plus, as I told already, or Cl plus. Okay, already we know that Cl plus is possible. So the same way, you take benzene plus chlorine plus FeCl3, you get chlorination of benzene, chlorobenzene. So the process is chlorination and the product is chlorobenzene. So there, what is replaced? H plus is getting replaced by Cl plus. Cl plus. Cl plus. Replacing H plus with Cl plus. That is called electrophilic aromatic substitution. And then nucleophilic aliphatic substitution. One nucleophile enters, another nucleophile goes out. SN1, SN2 both can be. Okay. Nucleophilic aliphatic substitution. This is nucleophilic aliphatic substitution only. This is an aliphatic chain. So nucleophilic aliphatic substitution. Then nucleophilic aromatic substitution. One nucleophile go into the benzene ring and the another nucleophile goes out. One example I can show you. Picric acid. Normally, nucleophilic substitution into benzening is quite difficult. Nucleophilic substitution into benzening is quite difficult. Can you tell me why? Nucleophilic substitution into benzening is very difficult because benzene is full of electron density. So nucleophile cannot penetrate. It will be very difficult to penetrate. But if you have nitro groups, that will make the electron density quite low. So if you make 2-3 nitro groups, so practically it becomes possible. Okay, so you have a compound like this, 3NO2, 246 position, and you have Cl here, 246 trinitrochlorobenzene. In this case, if you just give aqueous solution of sodium bicarbonate, not very strong base also, just aqueous solution of sodium bicarbonate, add this compound and just give shaking. Don't have to give any sort of heat or anything. Immediately the reaction will proceed and you will find the Cl is replaced by OH. Okay, that is called picric acid. But very toxic, not to touch by hand. So nucleophilic aromatic substitution, this is the example of nucleophilic aromatic substitution. Nucleophile enters, OH minus going in and Cl minus goes out. The nucleophilic acyl substitution. Acyl group is CH3CO type of group. RCO group is called acyl group. Okay. So in the benzene ring, instead of Friedel-Crafts, if you do the Friedel-Crafts reaction in benzene, do you remember Friedel-Crafts? Benzene ring plus CH3Cl plus anhydrous AlCl3. What do you get? Toluene. Okay. Toluene. Similarly, if you take benzene ring plus CH3COCl plus anhydrous AlCl3. So COCH3 will be attached in the benzene. That is called acyl substitution. Okay, aromatic acyl substitution. Because CH3CO group is acyl and acylation. If the CH3 or C2H5 getting added up in the benzene ring, it is called substitution with alkyl group, alkyl substitution. And if you get COCH3 or CO C2H5 type of group, it is called acylation of benzene. Alkylation and acylation.
So, in 2,3,4 trinitrobenzene, sir, H plus तो नहीं, कहाँ पर bना picric acid?
कोता H plus. Cl is getting replaced by OH.
ना बोले ना picric acid.
OH is acidic. Phenol is not acidic. Phenol is acidic, no? It is much more acidic than phenol because 3 NO2 group are there. NO2 groups are making the thing more acidic. Ordinary phenol is acidic. Then if you have 3 NO2 groups, it will be much more acidic, stronger acid. And that's an acid. If carbolic acid is an acid, why not picric acid? Got it? Carbolic acid is acid, na? We call it carbolic acid. Which one? Phenol? So why not picric acid? That is also acidic, much more acidic, stronger acid compared to carbolic acid. Because of nitro groups. Okay, so this is the substitution, nucleophilic substitution, saturated carbon, alkyl halide nucleophilic substitution. I have discussed all this. So 3 types SN1, SN2 and SNI. SN1, SN2 I have discussed in detail. Basicity versus nucleophilicity. Okay, just go ahead fast. SN1. Okay, I think continue next day because there are some more things left.